Einstein's theory of relativity, it's one of those ideas in science that just completely messes with your head. But what if the problem isn't actually the theory itself? What if it's the explanation? What if the way we've all been taught to think about it is, well, just fundamentally flawed? So, why is it so confusing? I mean, think about it. The theory predicts things that just feel wrong, like completely against our everyday intuition. The idea that a train, just because it's moving super fast, would physically shrink, or that time itself would actually slow down for the people inside. It honestly sounds more like magic or science fiction than science, right? It's just deeply, deeply counterintuitive. Okay, to really unpack this, we need to grab a tool from a philosopher named Alfred Korzybski. He had this incredible, simple idea. The map is not the territory. And it's exactly what it sounds like. The words we use, the theories we have, the diagrams we draw, those are all just maps. They're representations. They are not the real thing. Right, so the map is our representation. The territory is, well, reality. And this brings us to the big question for this whole explainer. What if all the confusion about relativity isn't a problem with the territory, with reality itself, but a problem with the map we've been using to describe it? What if our explanations have been getting it wrong all this time? Okay, so let's try to build a better map. We're going to explore a new framework that tries to do just that. It's sometimes called the Zionad chat model, and its whole goal is to build a much more precise map of reality by, get this, separating it into distinct, logical layers. Now, this right here is absolutely crucial. This model proposes a really strict order of operations. First, you have a map maker who defines a pure, abstract math world. Think of it like a blank canvas of geometry. Then you apply the laws of physics to that mathematical space. And only then, after all that, can you figure out what an observer would actually see. The whole argument is that getting this order right is the secret to making it all make sense. And here's the real game changer. This model argues that things we take for granted, like coordinate grids or this idea of simultaneous time, they don't actually exist in nature. They're not part of the territory. They are just tools that the mapmaker puts on the map to help us get our bearings, kind of like the grid lines on a road map. So the big mistake, according to this view, is treating that mathematical grid like it's a real physical thing that can actually stretch and bend and warp. So how do you test a new map like this? Well, the person who came up with this model did something pretty clever and kind of fascinating. They basically asked a neutral AI, which they called an independent space-time auditor, to act as a referee and decide which framework was more logically consistent. At first, the result was a total landslide. And honestly, it's exactly what you would expect, right? The AI threw 99% of its support behind the standard Einsteinian view. I mean, come on, it's a theory that's been proven right for 100 years. From GPS in your phone to giant particle accelerators, the new model, it barely even made a blip on the radar. But then, things got interesting. The auditor was specifically asked to analyze this new framework's really strict separation of concepts. Just look at the comparison here. The standard view, it treats coordinates like they're just part of space-time. The new view says they're just a tool the mapmaker uses. The standard view says the object physically shrinks. The new view says, no, that's a geometric illusion. See? It all comes back to that one core idea, the map versus the territory. And this is the part that's pretty wild. After digging into the logic, the auditor did a complete 180. It flipped its verdict, giving 75% support to the new framework. And why? Because, it concluded, the new model was just more logically sound. It never ever confuses the map with the territory. It keeps the math tools completely separate from physical reality. Okay, so this is all a bit abstract, right? What does this huge logical difference actually look like in practice? Well, let's use probably the most famous example in all of relativity to see what's going on: the speeding train. All right, so on the left, you've got the standard explanation. It says the train itself physically contracts. It literally gets shorter. But the new model, over on the right, says, whoa, hold on. That's a classic map territory error. It argues the train doesn't change one bit. What changes is your perspective. It's a geometric illusion, kind of like how a pencil looks shorter when you turn it and look at it end on. And this is such a brilliant way to visualize it, using 3D software like Blender. Think about it. In Blender, there's a perfect separation between an object's actual geometry, that's the territory, and what the camera sees, that's the map. If you want to make that train look shorter on screen, you don't have to actually go in and shrink the 3D model. Nope. You just rotate the camera. The object's true shape is never, ever altered. So really, the whole debate boils down to one simple question. Is the train actually shrinking, or are you just, in a geometric sense, turning your head to watch it go by? This new model argues that confusing the camera's view for real physical change is that classic fundamental mistake of confusing the map for the territory. And all of this leads us to the real heart of the matter. It forces us to ask a really big question, not just about physics, but about how we see and describe reality itself. So let's be super clear. The point here isn't to say that Einstein was wrong. Not at all. His equations are perfect, they work. The goal is to suggest that our explanations of his work could be a whole lot better, more rigorous, and way more intuitive. If we just cleanly separate our mathematical maps from the physical territory, maybe, just maybe, all those confusing paradoxes just disappear, and we get a much clearer picture of what's really going on. And this way of thinking, it goes so far beyond just physics. I mean, think about our daily lives. How often do we mistake a label for a person, or a news headline for the full story? But sticking with science, it really leaves you with a provocative thought. If our explanations of relativity have been tangled up in a map territory confusion for over 100 years, what other territories are we seeing all wrong, just because we're using a flawed map?